In problem number 1, my first step is going to factor 54. What times what is 54? I could use 9 and 6. Next, I'm going to factor 9, 3, and 3. That's how I got these two 3's. I'm going to factor 6. 3 times 2. That's how I got that 3 and that 2. This 3 was outside of the radical. It stays outside of the radical. My index is 3. That's why I'm looking for sets of 3 to come out. I have 3 3's to come out. That's where that 3 came from. 2n does not come out. It doesn't have enough factors. So 2n stays under the radical. So I'm going to go 3 times 3 is 9. So then I get this for my answer. And a common mistake kids will make on the quiz is they will forget to write their index. In problem number 2, I am going to first factor 16. Two numbers that multiply 16, I can use 2 times 8. And I'm going to factor 8. 8 is 2 times 4, and I factor 4, 2 times 2. So this is where I got all of these 2's, because these are these 4 2's. Then m squared is m times m. My index is 2 because it's not shown. That means I am taking out sets of 2. So I have 2 2's. That's where that 2 came from. I have another set of 2's. That's where that 2 came from. This 3 was outside of the radical, so it stays outside of the radical. I have a set of m's. That's how I got that m. And I multiply them all together. That's how I got that answer. In problem number 3, I'm going to factor 16. I get 2 times 8. This 2 is a prime number, so it goes right here. Then I'm going to factor 8. 2, 2, 2. That's how I got those 3 2's. My index is 2, so I'm going to take a set of 2's out. That's where I got that 2. Another set of 2's. That's where I got that 2. I am going to factor n squared. N times n. That comes out as a set right here. I had -1 on the outside of the radical, so it stays on the outside. I'm going to multiply them all together, and that's what I got. Problem number 4, I am going to first factor 12. What multiplies to 12? I picked 3 times 4. That's how I got that 3 right there. And what multiplies to 4? 2 and 2. That's where I got that set of 2's. My index is 2. I'm looking for sets of 2 to come out. So that's where that 2 comes from. My -1 is not under the radical, so it stays outside the radical. So that's where -1 comes from. 3 and n can't come out, so they stay under the radical. So I multiply, and this is what I got for an answer. In problem number 5, I am going to factor 343. To figure out what that factors to, I'm going to go 2 plus 4 plus 3 is 9. That's divisible by 3. That's how I figured out how to divide it by 3. So I divide by 3 and I got 81. That's where that 3 came from. Then I'm going to factor 81. That's 99. And I factor 9. And that's how I got those 3's. So that's where those 4 3's came from. In the original problem, outside the radical, I had -3. It stays outside the radical. My index is 4. I am looking for sets of 4's to come out. So I have 4 3's. That's where that 3 came out. Then I multiply them all together. That's how I got that answer. Don't forget to write your index of 4. In question number 6, I am going to multiply the square root of 8 times -4 square root of 2. So I'm going to factor 8 is 2 times 4. 4 is 2 times 2. So that's where I got these 3 2's under the radical. This doesn't factor, so that's where that 2 came from. My index is 2 because it's not shown, so I'm looking for sets of 2's to come out. So that's where that 2 comes from, and I'll take another set out. That's where that 2 comes from. Notice negative 4 is not under the radical, so it stays not under the radical. That's where that came from. And I multiply them all together, and that's what I got. In problem number 7, I'm going to multiply the square root of 4 times 4 square root of 4. So first I'm going to factor 4. 2 and 2. That's where these 2 came from. Next I'm going to factor the next 4. So I got 2 and 2. That's where those 2's come from. I'm looking for sets of 2's to come out. There's a set of 2's, so that's where that 2 came from. Take that set out. That's where that 2 came from. This 4 is not under the radical, so it stays not under the radical. And I multiply them all together, and this is what I get. In problem number 8, we are going to multiply the cube root of 9 times 4, the cube root of 9. So I'm going to factor 9, and I get 3 times 3. That's where these 2 3's came from. Next, I'm going to factor 9 again. I get 3 times 3. So that's where these came from. I am looking for the cube root. So I'm looking for sets of 3's to come out. So I have these 3 to come out. That's where this 3 comes from. This 4 is not under the radical, so it stays not under the radical. This 3 does not come out. So I multiply everything together and I get 12 cube root of 3. In problem number 9, I am going to multiply negative 4 square root of 3 times 4 square root of 6. 3 doesn't factor, so it stays under the radical. 6 factors as 2 times 3. That's where that 2 came and that 3 came from. Negative 4 and 4 are not under the radical, so they stay outside of the radical. That's where these came from. So I'm going to go ahead and take out a set of 3's. That's where this 3 came from. And I'm going to multiply them all together. That's how I got this answer. In problem number 10, I'm going to multiply negative 1 square root of 3 times negative 1 square root of 12. And I'm going to factor 12 as 4 times 3. That's where that 3 came from. And I'm going to factor 4, 2 and 2. That's where these 2 came from. This 3 doesn't factor. That's where it came from. I am looking for the square root, so that means I am looking for sets of 2's to come out. So I have a set of 3's that came out. I have a set of 2's that come out. And I multiplied them all together. That's how I got this answer. In problem number 11, I have 3 times the square root of 8 divided 4 square root of 2. I am going to factor 8. 2 times 4 and a factor 4, 2 times 2. That's where I got these 2's under the radical. And I notice right away these 2 will reduce with each other. So I am looking for sets of 2's to come out. I have a set of 2. That's where this 2 came from. So I'm going to go ahead, 2 times 3, divide by 4. That's how I got 3/2. In problem number 12, we have the cube root of 27 divided by 2 cube root of negative 8. I'm going to factor 27, 9 times 3. That's where that 3 came from. I'm going to factor 9, 3 times 3. That's where those 3's came from. I am going to factor 8. So 2, I'm going to make it negative, and then 4, I'm going to factor 4, 2, and 2. That's where these numbers come from. I am looking, this 2 isn't under the radical, so it stays outside of the radical. I am looking for index of 3, so sets of 3s to come out. So I have one set of 3s, that's where that came from. I have one set of negative 2s, that's where that came from. Then I'm going to multiply them, and I get this answer. In problem 13, I have the square root of 4 divided by 4 square root of 16. I am going to factor 4, 2 and 2. That's where these two come from. I'm going to factor 16, 4 and 4, and I'm going to factor 4, 2, 2, 2, 2. So that's where all these 2's come from. 4 is not under the radical, so it stays outside, not under the radical. I am looking for, I have an index of 2, so I'm looking for sets of 2's to come out. That's where this 2 comes from. Then I have another set of 2's and another set of 2's. That's how I got that 2 and that 2. And I notice right away this reduces and this reduces. So I'm going to multiply them. That's how I got that answer. In problem number 14, I have the square root of 2, which does not reduce, so it stays the square root of 2, over the square root of 9, which reduces to 3 times 3. So I have a set of 3's that come out. That's where this 3 came from. And nothing else reduces. That's my answer. In problem 15, I have 4 square root of 12 divided by the square root of 27. I am going to factor 12. I get 4 times 3, so I wrote the 3 right here. And I factor 4, 2, and 2. That's where these 2's come from. The 4 is not under the radical, so it stays not under the radical. I'm going to factor 27. 9 times 3, that's where that first 3 came from. 9 is 3 and 3, so that's where these 3's come from. And I notice I can reduce. This 3 reduces with this 3. They're both under the radical. I am looking for sets of 2 numbers to come out. That's where that 2 comes from. And then I have a set of 3's. That's where this 3 comes from. And I'm going to go ahead and multiply them. That's how I got that answer.